All right, ladies and gentlemen, this is the last lesson of our surface area unit. Don't forget to write down the page number of your notes. I'm on page 140. Today's date is the 12th of April. Yes, it is Friday. Yes, I am the mean person giving you homework on the weekend, but remember that you do not have a quiz or test in this unit, so kind of a trade-off there. The title of our notes today is How Can We Use Surface Area to Solve Problems? So something that I strive for is for you to always understand what the real life connections are to what we learn in math class. Sometimes it may seem like, when in the world will I ever use this as an adult? Well, that's the goal, is to show you when you might use this. So surface area can be used to solve multi-step problems. We're going to do one question together, and then you'll do the remaining 3 on your own. Notice that today's notes are pretty blank. That's because there's only 4 questions, and we're going to do one now. So number 1 says the cereal box shown at right is cut from a piece of cardboard with 600 square inches. How many cereal boxes can be cut from this piece of cardboard? So first, what we want to do is start with what we know. So I'm thinking, I may have to reread it a couple times, but I'm going to read again that the cereal box shown at right is cut from a piece of cardboard with 600 square inches. Okay, so I have 600 square inches to work with of cardboard. And I want to figure out how many cereal boxes can be cut from this piece of cardboard. So basically, how many of these cereal boxes could be used from this piece of cardboard? So I have to figure out what the surface area is of this cereal box and see how many of these can go into this. Otherwise known as, we'll be dividing 600 by whatever the surface area is. So I need to be able to figure out what 600 is divided by whatever the surface area is of the cereal box. Running out of room. This right here. So again, I know that because I have 600 square inches of cardboard to work with, and here's the cereal box that I want to cut from this cardboard. So I want to see how many of these can I get out of this total. So I'm going to take this total, divide it by whatever the surface area is of the cereal box, and that should tell me my answer. So let's go ahead and find the surface area of this box. What I like to do, and you guys probably know this by now, is to create a net from this cereal box. So I'm going to take this cereal box and I'm going to create a net. So I have a rectangular prism, and here I have the front, and I may just do a little bowl of cereal to know that that's the front. Okay, attached to the front of my cereal box are my 2 sides. One side of the cereal box, the other side of the cereal box. I have the front of the cereal box. I also have the back. The back is also connected to the side. So here I'm going to draw the back. And if that's confusing at all, then I would label each one as the front. Maybe we call this the side. We call this the other side. We call this the back. Now we're missing 2 more pieces because this is a rectangular prism. We have the front, the back, the side, the other side. We also have the top and the bottom. Without a bottom or top of the cereal box, we would have some issues. I'm going to draw the top of the cereal box connected to the front. So if I were to cut the sides on the top of the cereal box, the top would be connected to the front, and I'll also connect the bottom to the front. So this is my net of this cereal box. And again, if I want to label these to make sure that they're clear, I'm going to label this as the top and the bottom. So now that I'm organized, what I need to do is decide where the dimensions of this cereal box go on the net. I'm going to start with the front again, and I can see that the front of my cereal box, it's pretty tall. It's actually 12 inches tall. So this length right here is going to be 12 inches, which also the side is also that tall, right? They meet together. So I know that this side is also 12 inches, which would make this side 12 inches and would make the back side a height of 12 inches. They all have the same height because when we fold them all together, it makes a nice cereal box. So we have the height. The next, what I'm going to do is the length of the cereal box. So it's 8 inches long, and I'm going to use a different color for that so that we don't get them mixed up. I know that the bottom here, length, is going to be 8 inches. So if this is 8 inches, this is also going to be 8 inches. This is going to be 8 inches, and this is going to be 8 inches. So all of these are 8 inches. Now there's actually another dimension that's going to be 8 inches. Remember that the opposite sides are congruent. So the opposite sides of the cereal box, for example, the front and the back, are going to be congruent or the same. So here I have a height of 12, here I have a height of 12, here I have a length of 8. So that means the length of the back is also 8 inches. Okay, the opposite sides are congruent, so that would also make this 8 inches. Now I'm missing one more dimension, and that's the width of the cereal box. So how wide is it? Here we have that is 2 inches wide. So that means the sides, which we will do in green, are 2 inches. 2 inches, the other side is 2 inches. That means this would be 2 inches, 2 inches, and so on. Again, this is a review. We've done this in class. This should hopefully be clear to you by now. So I'm going to go ahead and find now the area of each of those. Okay, and if I want to, I can go ahead and label the front, the back, the side, the top, and the bottom, each of those. Okay, and notice I only put one side. That will be multiplied by 2. The front and the back are going to be the same. The top and the bottom are going to be the same, and the sides are going to be the same. So for